Hi, what are you doing? I wasn't expecting to see you quite yet. I wasn't ready for school to start yet. I'm just kind of making my breakfast. See my dog? We didn't expect you yet. What are you doing? Look it. I'm making an egg and some toast. I wasn't ready for school yet, but it's good to see you. You know what? It's kind of funny that you showed up when you did, because making breakfast like this, it kind of reminds me of, guess what? Chemical reactions. You're right. Hey, why don't you let me clean this mess up here, and I'll be back with you in a second. I'm going to go ahead and just share a video with you so that you're not just watching me clean my kitchen. Knuckleheads, I wasn't ready for you quite yet. Let me get, well, I can't quite see it. Doggone. Here we go. All right, watch this video real quick, and I'm going to clean up my kitchen, and then we'll be back to talk more about chemical reactions, okay? Knuckleheads, I wasn't ready for you.
You know what's a really great way to learn about science? Baking. After all, baking is pretty much just chemistry, and chemistry is the science of different kinds of matter and how that matter can change. Sure, some of the equipment used in baking and in chemistry isn't quite the same, but both baking and chemistry require careful timing and measuring, and both of them result in the formation of a mixture. For example, you can change matter like eggs, milk, flour, and sugar into a tasty dessert. Now, you already know that a mixture is anything made by combining two or more different things. In some kinds of mixtures, like the fruit salad we had at our picnic, can be separated back into the substances that made them. But that's not true about all mixtures. Sometimes mixing things together makes a whole new substance. We call this a chemical change. But what is a chemical change? A chemical change is a change that occurs when the particles that make up two or more substances are rearranged to form a new substance. Unlike the mixtures from our picnic, chemical changes usually can't be undone. Let's observe an example of a chemical change. Observe, people. We're not trying this at home. When we observe a lit match, we see that the match burns. As it burns, it changes into burnt wood and ash. We can't change this ash back into a match, so burning is an example of a chemical change that can't be undone. But wait, there's more. Chemical changes often make matter change color, like the blackened remains of the match. Sometimes chemical changes make smells or release light or gases, and lots of chemical changes require either the giving off or taking in of heat. A burning match gives off light, smoke, and heat. All of these things are evidence that when we look at a burning match, we're looking at a chemical change. Now we can do a simple investigation to show how some chemical changes can yield a seriously yummy result. When we mix the ingredients of a cake, we're mixing together different kinds of matter. Say you have flour, sugar, milk, and eggs. When you put them in a bowl and stir, you're mixing several different substances together to make cake batter. And when you pop this mixture into the oven, after a short time, you have a new substance, cake. Now, before you eat it, let's check this science cake for evidence of a chemical change. Did the reaction give off or take heat? Definitely. The cake batter needed the heat from the oven to change into cake. If we left the batter on the counter, it would stay batter. Is there a color change? Check. The batter in the pan was yellow, and now it's a nice golden brown. Is there any smell? Well, if you've never been in a bakery or some grandma's kitchen or just never smelled a cake baking, then I feel bad for you, because it smells amazing. Were any gases released? Let's look at our cake before and after. Before, we have a wet, gooey batter. After, we have a nice, fluffy cake. As the cake was in the oven, some of its ingredients released carbon dioxide gas. We can see evidence of carbon dioxide when we cut the finished product. All those little holes in the spongy-looking cake are caused by this gas. Our last piece of evidence that we've witnessed a chemical change? This change can't be undone. For example, we can't get the water we put into the batter back out of this cake. Even if we were to squeeze it really hard, we'd get crumbs. So let's not try. So, a chemical change is a change that occurs when the particles that make up two or more substances are rearranged to form a new substance. Most of the time, chemical changes can't be undone, and we can tell they're occurring by observing them and noting things like changes in color, release of smell or light, and whether they take in or give off heat. All in all, I'd say that sniffing out chemical changes can be a piece of cake.
What'd you think of that? All right. Well, I'm glad to see you this morning. Welcome back to science. I'm going to stop sharing this one. See, I'm still kind of getting used to what I'm doing here. Good morning. Hey, I want to talk to you guys a little bit more about chemical reactions. And specifically, we didn't really get a chance to talk about, we talked about it a little bit, but we didn't really get to focus on the properties and how we know a chemical reaction has taken place. So hopefully that video kind of helped you out a little bit. Let me share something else with you. So go to my share screen, and I'm going to go back to this and share. Sorry, I want to, I should have just done that. Hang on. Okay, get out of there. Okay, sorry you guys. There we go. All right, so just a reminder, I got a lot of this information from Amplify. Reminder of our key concepts for chemical changes or chemical reactions. They're different than physical changes because physical changes, remember, the atoms don't separate and rearrange, they stay together. So the groupings of atoms stay together, they just increase or decrease in kinetic energy, and so they change phase. Or you could cut them, or you could shred them, but basically it's the same substance that hasn't changed. Well, in a chemical reaction, look, during a chemical reaction, atoms do not change from one type to another. So an oxygen atom is always going to stay oxygen. A carbon will always stay carbon. It doesn't change from one to the other. But during a chemical reaction, atoms rearrange to form different groups of atoms, right? Okay, so what does that mean? I took, remember Amplify, we've got that simulation where you can go into lab A and you can kind of practice mixing different chemicals. Those of you who were gone the last couple days prior to spring break, you guys didn't get a chance to do this. So I really encourage you to go into Amplify and go into you know what, I've got a picture in the next page, I'll show it to you. Just click straight into the sim and go to lab A, and it allows you to pick different chemicals that you want to see if they mix together. So just mess around with that a little bit. But I chose sodium and chlorine, and then we know that when sodium and chlorine are coming together, those molecules will rearrange and form a new substance called sodium chloride, which is table salt. Just a reminder that sodium is sodium because it has different properties than chlorine. We know that different substances have different properties, and that's how we know that they've got a different atomic makeup, okay? On this side of the formula, we've got what we call our reactants, and the reactants are the chemicals that get put together and they do the rearranging. So sodium plus chlorine, and remember I've got my arrow right here, that means yields sodium chloride, table salt, and it has completely different properties than these two substances that are in the reactant. So again, that's how we know that a chemical change has taken place, because that substance has completely different properties than the two the two substances that make up the reactants. So again, if you want more practice, go into your Amplify. Those accounts are still active, and although we're not going to be doing a lot in Amplify as far as the discussions and things, you can still use your sims. And I encourage you to do that. We'll pull out some articles every now and again, and I'll give you those, but that's as much as what we're going to use in Amplify. But this is the science app for chemical reactions, and you guys are welcome anytime to go in there and kind of mess around with that. So how do you know if a chemical reaction has taken place? In the video that you watched, it kind of alluded, she talked about it a lot, but I want to remind you. So first of all, it's going to either take in or give off heat. My eggs that I was making, that required the egg to take in energy. In the toast, it was taking in energy. Next week, I'm going to show you some demonstrations and encourage you to try some things at home where your chemical reaction will give off heat. You'll be able to feel the heat. A really easy one for you to think about is what she talked about in the video with the match. You know a chemical reaction is taking place because heat was given off. Also, the creation of gas, and a lot of times we see that in bubbles. At 10 o'clock on Monday, I'm having my first office hour, and that means that's going to be a live Zoom meeting where you guys will come and join me on these meetings, and we'll be able to talk face to face. And so I'm going to do a couple demonstrations live, and so we'll talk about that. But one of them will involve the creation of gas. And again, all these demonstrations that I'm going to be doing, I'm going to be using household items so that if you want to try them at home, you can. You just have to make sure that you have parent permission and probably parent supervision on a couple of them, okay? Another way that I know that a chemical reaction has taken place is that it gives off light. So again, think about the match. It gives off light. There's some really cool experiments that you could do. You have to have some special chemicals, and I might find the videos of those and show those to you, but they give off light after or during the chemical reaction. And then the other thing is, this is an easy way to determine whether a chemical reaction has taken place or not. Look to see if it has a change in property, okay? So a change in color. Look at, here's my bread that I had before, and this is my toast. That's a change in color. Now, that doesn't always mean that it's a chemical reaction. Think about if you painted your house, right? You're going to change the color of your house, but a chemical reaction hasn't taken place. It's just a physical change because it can be easily removed. It's not changing the arrangement of the atoms. Or you could take marker on a piece of paper and color the paper. That hasn't, a chemical reaction hasn't taken place. That's just a physical change. You can also tell if there's a change in the property of smell. So again, with my toast, you guys, my house right now smells like toast. It smells amazing. I love toast. And then you can also tell if further chemical reaction has taken place because of smell, because look, I burnt one. This smells different than this one for sure. Change of texture. Think about in the video, she was talking about cake batter. So cake batter has a different texture than the actual cake, right? And then the last one is flavor. And I want you guys to think about this, especially as we move on. Flavor. Why does bread taste like bread and toast taste like toast? In fact, toast, in my opinion, hang on, I'm gonna pause. How do I start this? Just a second. Hang on. Sorry about that. I knew that was going to happen. I've got some people that are pouring a new driveway, and so we've got workers over there. I knew that was going to happen. I'll have to lock my dogs up next time. Sorry about that. Anyway, I was asking you to consider why toast tastes better than bread, and it does. Sorry, but it does. So I've got a challenge for you. Let me share my screen again. Okay, so here is your extension activity. And what I mean by extension activity is this isn't homework, okay? But I want you guys to continue learning on your own. This would be like if we had 15 minutes in class where I gave you class time to work on something, to look something up, to talk with a partner, to do some discovery on your own. So that's called an extension activity. And I'm gonna have quite a lot of these in my lessons as we move forward. So today's extension activity is this. I want you to do a little bit of research, and I want you to specifically research something called the Maillard reaction. I know it looks like Maillard, but it's a Frenchman's last name, a French chemist's last name, and you pronounce it Maillard. So the Maillard reaction, I want you to search that and answer the question, why does it make toast taste better? The Maillard reaction is really important in cooking. So look at number one. I want you to spend some time on YouTube or the web searching the Maillard reaction. Some videos on YouTube are pretty easy to watch and understand, and some of them get really technical and start talking about chemical compounds and the names of the different chemical compounds and the reaction that's taking place. You don't need to know that. I just want you to know kind of what's going on and why that is kind of an important thing in cooking. And then over the weekend, I want you, instead of typing a response and just verbalizing that response, I want you guys to prove to me that you understand the Maillard reaction by finding a model in your own home, okay? So what I'd like you to do is make, bake, cook something this weekend. And it doesn't have to be anything extreme at all, but not toast. That's my example. I don't want you to use toast. But I want you to post your pictures to the discussion thread. And then we can start a conversation about how we know that that Maillard reaction took place in your model, in your physical three-dimensional model. Okay? If you have any questions as we're going through this, you can email me. And then on Monday, our lesson on Monday is I'm going to show what you guys have posted. You guys can see each other's in your class period, but you can't see other class periods. So I'm going to show you what everybody's put in. So take a second to do that. Now, if you can't cook, you don't have anything to cook, you don't know what to cook or bake or make, go to your pantry. You guys, there's tons of stuff that's already had the Maillard reaction in pre-made food for sure. So look in your pantry. You can always just show a demonstration of that, okay? Let me know if you have any questions, and I will talk to you guys later. Hang on. How do I do this? I'm going to do this. Okay. I'll talk to you guys later. See ya. How do I stop my... This is so awkward. I want it to be super smooth and be like, okay, guys, I'll see you later. I'm going to stop share. There we go. That's what I need to do. I'll get the hang of this. I'll see you later.